Morning, everyone. So, welcome back to another episode of Still Connect webinar. And I'm your host today to talk about steel and building related topics. So, of course, before we start, feel free to ask any questions relating to this topic on the Q&A box on the side. And meanwhile, we'll have actually two polling questions to be asked during the session to gauge your understanding and also your feedback about the specific topic. And of course, just reminders to fellows architects and engineers. If you wish to claim your LAM CPD points or BEM CPD hours, please stay through the entire webinar, and a survey form will pop up on your screen once you exit the webinar at the end, right? So you can actually fill up your LAM and also BEM membership number in the form. All right, so let's start. So today's topics would focus on the common influence of palm oil mill and smelting plant on buildings. Okay, so these pictures, the one that's shown here, actually shows a good indication of what is the effect. But for those who are not familiar or have not encountered this kind of building design before, let me just share with you the insight that we have and also the studies that I have gone through. Right. So to start with, let's just talk about the weather, right? So for Malaysia or Southeast Asia, normally the weather itself is what we call tropical weather. That means other than having sunny day all year round, we also have abundance of rain, right? With that, the air and also the environment itself is highly humid. So I believe, people coming from overseas or elsewhere in the fall season would agree with us that the weather is so humid all year round and it's expected. So with that, of course, today's topic will be about water, right? And also the basic of how water transform into different states, right? So in basics, water can be in three forms or three states, depending on the situation or the scenario that it is in. So of course, the first one is solid, which typically we refer to it as ice. Okay, this is purely for water, right? And the second one is what we call liquid. So this one is when the water condenses from a vapor state or a steam state, or it comes from when the ice start melting. Okay, and the third one is gas state. So this is where your water is heated to the point where it starts moving too fast and then it's escaping from being a liquid. So it becomes what we call steam. Okay, so this steam as well as condensation liquid is what we will be discussing in today's topic. Okay, so how is palm oil mills or palm oil industry relevant to water, and how does it affect the building? Okay, so before we start this topic, let me just ask the first polling question. Okay, how often do you think the palm oil mill buildings need re-roofing? Okay, and the reason why we ask this is because we want to gauge your understanding, or perhaps if let's say you have experience, what is your experience, right? Has it been always 1 to 3 years within this time span? Second option, 3 to 5 years. Third option, 5 to 10 years, or even longer, 10 to 20 years. Of course, if let's say you have no experience on this, you can always take a guess, right? We just want to know your understanding, and of course, later on, I will actually share the some of the insights that we have based on our years of conducting on-site investigation as well as inspection. Right. So 10 more seconds to go. So we do encourage you to actually fill this up so that you can actually understand what are the the whole participation's thoughts is. Okay, so let's see the result. Okay, so most of you say 5 to 10 years. Okay, so I mean, if let's say your building is within the 5 to 10 years, I think you're expecting a really well-designed palm oil buildings. Of course, if let's say certain, there is actually certain part of the buildings that will be even shorter. Okay, I'll share why. So these are examples of some of the palm oil mills. Okay, so you see like a lot of chimneys coming out. It could be a stacked chimney, meaning emitting out smokes, right, because of burning. Or it could be emitting out a lot of steam. So you normally see if let's say it's white color, normally it is releasing out a lot of steam. Okay, so the whole palm oil mill process actually starts, of course, from the raw fruits itself, but this is a simple overview. Of course, you don't need to focus on so many part of it. So you just need to, today we are just looking at the beginning part, which is what they call sterilization process. All right. So sterilization process is basically cooking the fruits. Okay. So in this process, it actually utilizes a lot of steam. Okay. And later on, I'll tell you how the steam is generated and also how is it affecting the building. So you can imagine it from a layman's term. You can actually use an analogy is boiling your water, right, at home, right? Either boiling water, right, or having it in pressure cooker. So most often you will see steam coming out when the water is boiling. Okay, and for pressure cooking, like in the pressure cooker, so you will have your food inside the pressure cooker, and then you put water inside, and then you cook it in a high pressure, right? This will be very similar to palm oil industry in the sterilization process. So once it's done cooking, then you open the lid, right, and you see a gush of steam, coming out from the pot. Okay, and last will be when the steam sort of condenses onto a colder surface, as what you can see from this picture itself, right? So all these are a cycle of cooking the palm oil fruits, right? So in actual, the objective of boiler and sterilization process does not go far from there. It's just in the scale of bigger scale, right? And it's the system itself is much more complex. So to start with, in the industrial setting, normally they use boiler to generate the steam. Okay, so this example itself shows how a boiler looks like on the external, and then there will be pipes connecting from here to all the areas or all the processes that requires steam, right, for their process. Okay, and typically on this boiler itself, there will be some pressure regulating valves, right, where the pressure will be released out from the chamber. So the reason is because it is different from your normal pressure cooker in the sense where in your pressure cooker, the heat can only go up to so high. And I mean, the amount of heat that is put into this pressure cooker is normally lower than a boiler. So for boiler, it is highly pressurized and then there will be a lot of heat generated. So they would sometimes need to lower down the pressure so that it does not explode, right? So normally they will have a regulation valve. And when they open up the valve, then there will be steam coming out from here. Okay, so this is the first source of steam, right, from the boiler. Of course, in the sterilization process, what it does is it will take the fresh fruit bunch, right? So these are the raw material for palm oil. Okay, so they take these palm fruits from the plantation, and then they ship it to this process palm oil mill. And yeah, so typically we call them fresh fruit bunches, okay, or FFB in short. Okay, so it's not Facebook, okay, it's FFB, fresh fruit bunches, okay. And from here, all these FFB will be loaded into this kind of large drum, okay. And this is where they will load it into the chambers that you see in this picture, right? So they will load it in, and then all the pipes on top that you see are steam coming from the boilers, okay? And what happened is that once it's loaded in, they'll lock it tightly, seal it properly, and the steam will start cooking the FFB. All right. Most often is using high pressure steam. So the steam coming from the boiler is high pressure. So in this state, it will actually cook the fruits faster. Okay. And once or upon it being cooked, it will be taken up. Right. Just like the pressure cooker. Once it's cooked, then you release the pressure, then you take it up. And this is where there will be a lot of steam releasing from the chamber itself. Right? So just like the boiler, there'll be steam releasing out, but over here, this is where the steam will be let out freely. They don't. I mean, basically, most of the steam just goes everywhere, right? You don't know where it goes. Okay, and because of this, when we actually conduct our inspection, most often we look at places where it's similar to this sterilization process. Okay, and what happened is that the sign of wearing for the cladding would be first, you will see droplets, water droplet sign, where it in the form of white dots. So these white dots, sign of white dots, or sometimes there will be watermarks, depending on how intense is the steam condensing onto all these cladding. If let's say it's not so intense, then you see dots. If let's say it's very intense, then you see drip marks, right? So these are actually sign of heavy oxidation, because as you may know, a palm oil mill is like many other industries. Most of them are actually running 24/7 to keep up with the efficiency as well as the productivity, right? So what happened is that it will constantly, the cladding itself or even the steel sometimes will be exposed to steam, right? 24/7. And this is where it is very different from when the cladding itself is exposed to rain. Yeah, so this is very frequent and on a high frequency. And over the time, depending on how intense it is, it will actually accelerate the corrosion of the places where it is in contact with. So it will start with oxidation. All right, it could be white spots. Then it will eventually go to become rusts. Right, as you can see from this picture. Okay, so this picture itself, you can see the rust only happens on places directly above the sterilization chamber. All right, so that means that when the steam is released out, then when the chamber is open, the steam's release upward, right? And this is where it will. These are the evidence that the location where it condenses at. Okay, and eventually the roof itself will start having leakages and all that, so it will be having holes. Okay, so all these roofs can be showing signs of dots, white dots and all that. Those are perforated holes. Okay, and of course on a severe case, it could actually lead to even the steel structures failing, right? Because some of the steel structures might not be protected properly, and having also exposed to the same type of humidity and as well as steam, it starts rusting. And this is of course the worst case scenario that you can see, okay, or we have seen. All right. So of course, the straightforward answer to this kind of industries or this kind of processes is to actually prevent the steam from releasing internally. Of course, most often when we go and do all this inspection, it is very rare that we see all these machines putting its place outward or outside, right, without any roof. So of course, I'm no expert in designing the processes, but this is the angle that we want. If let's say you want to prolong the cladding, is find a way to actually eliminate the steam from internal environment. All right. So of course, we do also see some efforts where sometimes they will actually place the chimney right outside of or right next to the building. And in this specific photo itself, we observed that the chimney itself was perhaps releasing the steam that is too close to the building. So what happened is that because of wind direction, so the steam itself get blown back to the building, right? And as you can see, it actually went under the roof as well. So the height of the chimney as well as the distance of the chimney away from the building is also crucial, right? Depending on the environment. And sometimes this is another example where we also see the chimneys being placed on a 90-degree angle away from the building. I mean, there are many solutions out there, and I believe our engineers is able to do a design that would meet certain requirements, right? And the end goal is again to eliminate steam from releasing inside. Okay. So of course, then there will be other solutions which I will also be presenting together with this second topic. All right. So the second topic is smelting plant. Okay. So before we start this topic, again, there'll be the next polling question that we'll be posting. All right. So the question, as you can see from the pop-up screen, is that what kind of byproduct do you think is emitting from this smelting plant? Okay, so most often when we encounter with the building owners, they might say, "Oh, the building is very corrosive, right? The processes is very corrosive." But those are very general statements based on what they saw and effect of the process. But we just want to know what is your understanding. So there are 4 choices here. So the first one is when the smelting plant actually emits corrosive chemical emission. Is this true? All right. Smelting plant emits a lot of hot, humid air. Is that true? Right. And the C is actually combination of A and B, right? Both corrosive chemical emission as well as hot, humid air. And last will be not corrosive, no corrosive emission at all, right? So what is your thought on this? So let's see the feedback. All right, so most of you actually stated that it is combination of corrosive chemicals as well as hot, humid air. All right, so based on my observation, the first one, corrosive chemical emission, is not so much because it it depends on the types of metals that you are melting. But most often, what we see is actually the latter, which is hot, humid air, and this is again related to moisture, and again coming back to the state of water, right? So just to give you an idea, or just a straightforward description of smelting plant, it is to melt the metal at high temperature. Okay, so most often you can see like melting, for example, like melting steel, you need well over over 1,000 degrees Celsius to actually melt steel, right? And some other metals could have a lower temperature, but most often is well over 500 degrees Celsius. Okay, and this hence created an internal environment that is extremely hot and humid, right? So this photo itself, you can see, right? The worker actually are equipped with a very special type of personal protective equipment when they are working very closely towards the molten metal, right? When the metals are like red hot. So and at the same time, this kind of environment is very is a high risk area in terms of safety, right? Because it could start splattering the molten metal outward. If, for example, if let's say it is exposed to moisture. So just imagine you have a hot pot of oil and then you drop water droplets inside, then it will start splattering, right? So same scenario that happened at the hot oil with water, with molten metal with water. So it will splatter and it will actually be very dangerous. So how does this relate to the state of water, right? So in this specific process, we'll be talking about condensation. Of course, unlike the earlier process of palm oil mill, you can see obviously there are actually a lot of steam releasing out from the sterilization process. In smelting plant, is much more subtle, right? That you normally don't expect steam coming out from the molten method because most often they don't contain moisture, right? So with that, I would like to just introduce you to this term, psychrometric chart. All right. So this psychrometric chart is typically, if let's say you're an engineer or you have an engineering background, then you'll be familiar with this term. So psychrometric chart is what you see here, the chart, right? Don't worry, you don't have to really understand what goes on, in detail. But I would give you a more layman explanation for this chart, right? So this psychrometric chart itself is actually to gauge what is the state of liquid, or state of water in a certain environment, depending on the pressure, depending on the temperature and so on. So it will give you an understanding of what is dew point also, right? So basically, dew point is something that you normally refer to as, say, morning dew, right? So you normally see water formation or condensation happening on your windscreen when you sit into your car in the morning, or perhaps you go for a morning jog, then you see all these say water droplets forming on the leaves, right? So these are what we call dew, morning dew, right? So dew point is very similar to that, right? In fact, dew point is the phenomena where water water vapor condensed to become water droplets. Okay, so again, it has to do with largely to do with the temperature and humidity, right? So our come back to our tropical environment. Our tropical environment normally is very humid and very hot, right? So this will be a very useful chart normally to gauge when will the water condense, right? Of course, if let's say you are not familiar with the chart, it's fine. We actually found that there's actually a table where they tabulate out the temperature versus the relative humidity table. So to determine when will the water condense, right? So this is a zoom out version. So you can see the different range of temperature on the row, and then you can see a different range of relative humidity on the column side. And later on, we'll actually use this table to address you why we think a smelting plant will have this the risk of water condensation, right? And how to actually determine that, right? And also eventually how to actually prevent it. Okay, so dew happens in two different scenarios, two different variables I mentioned: humidity or temperature. So first, humidity. So if let's say the relative humidity, RH, normally we call it RH. So if you have a so-called those relative humidity gauge, then you will know what is the relative humidity of your room, right? So if let's say the relative humidity reach to 100%, so what it means is that the air around the gauge itself will have 100% of moisture within the air. The air will have already carried 100% of what it can carry in terms of moisture. So if let's say there will be more steam introduced to the air, then there will be more condensation happening on any surfaces, right? So to keep the relative humidity at 100%. And relative humidity will never go beyond 100%, all right? So what happens is that it will actually condense. The water will condense to become water droplets to maintain the RH at 100%. So this is the first variable. And the second variable is where when the temperature start reducing down. So typically, you can only see morning dew, or so-called dew in the morning. That's why it's called morning dew. Okay. So it's also because in the morning it's colder. So just remember that, so that when the water encounters a colder surface, then it will start condensing. So that is where it reaches its dew point. So when the temperature of the air starts reducing, then it will start condensing, right? So this is because why, right? If let's say you have a chamber with hot air, right, inside, because perhaps like a boiler, so you heat it up until all the water becomes steam, right? So this is the amount of air, the amount of water the air can carry, okay? But if let's say you cool it down, what happens is that the air itself will no longer be able to carry so much moisture. So this is where the air started forming droplets so that they can actually release out the moisture, and the air will be colder, right? So this kind of phenomena, you can see it commonly on several places. And one of the places is if let's say you take out a cold beverage or cold drinks from your fridge, and very soon you'll see, oh, there's actually moisture forming on the surface of the cold drinks like Coca-Cola or a cup of ice water. And here, actually, there is, if you zoom it closer, then this is what you'll see. The part where the inner side of the glass and the outer side of the glass is not filled, I mean, the inner side of the glass is not filled with cold water. The air itself hasn't reached the dew point. So what happens is that the water will not condense onto it. But the part where it's filled with cold water, so what happens is that because there is actually a temperature difference between the internal and external, what happens is that the external air, which for example can be 30 degrees, so it encounters a very cold surface and then hence reach the dew point, right, and start condensing onto that surface, right? And there is actually another example. If let's say you have seen heat exchanger or so-called air conditioner fins, sometimes you see droplets coming out from there. So this is also because the fins itself is cold, right? The pipes are cold, right? Because of coolant, because of the cold liquid inside. And the outside air is hotter, so it will actually start condensing onto the surface. Okay, and coming back to our topic of smelting plant. All right, so just imagine smelting plant. Normally smelting plant, they would not stop the production because in order for them to heat up the furnace or whatever machine they need to run, it takes a lot of energy. That's why it is normally a 24/7 factory. So having a 24/7 factory, especially in Malaysia, has a certain risk to it. So this is the risk. Normally, if let's say your factories is operating at night, all right, we're just talking about nighttime here because that is where dew happens. Okay, the factory itself will be having normally a higher temperature compared to outside. Right, outside is cooler, and inside is hotter. And if we zoom into closer, right, to the roofing area, so let me just put an example here. In internal temperature is around 40, right? So if let's say you're talking about smelting plant, where directly above the furnace, normally is well beyond 40 degrees Celsius, all right? And the temperature outside, let's say 23 degrees Celsius, okay? Then what happens is that you have a difference in temperature, okay? And let's say the roof surface itself, the roof temperature is 26, right? Because of conduction from both sides. So it is reaching a surface temperature of 26 degrees Celsius. And from the internal, you have a very humid air, right? So this humid air, what happens is that it can be quantified in terms of how much moisture it can carry. So here we just put a scenario of relative humidity of 50%, all right, RH of 50%. So remember the table that I showed you earlier? So how for people who are not so technical, you can understand this table is. So let me zoom in closer. Just now I mentioned the internal air temperature is 40 degrees Celsius, right? So you look at the row, right? Then you look at 40 degrees Celsius. Then you look at the relative humidity, RH, of 50%. Okay, then you look at the intersection of these two. So it will show you the dew point, right? Dew point is in the unit of Celsius as well, right? In the unit of Kelvin, Celsius, or even Fahrenheit. So in this case, with the scenario of 50% RH and 40 degrees Celsius air temperature, the dew point is at 27.6 degrees Celsius. All right. So let's go back to the example that we showed earlier. So in this case, what happened is that the dew point is 27 degrees Celsius, but then your roof surface temperature is actually 26, which is well lower than the dew point of the air. All right. So what will happen here is the air internally will start condensing. The water will start condensing onto the surface of the colder surface. That means, the surface where it has reached temperature lower than the dew point, right? So in this case, it's the roof. All right, the behind the backside of the roof, and due to the condensation, some of the moisture will be taken away from the air. So now the air's relative humidity is 45%. Okay, the relative humidity will be reduced. So now you look back at the table. So the table says if let's say you change the relative humidity from 50% to 45%, then the temperature, the dew point will be at 25.8 degrees Celsius. Okay, so in this case, then there will be no longer any more condensation happening because the dew point is below the surface temperature. So this is how we determine what kind of temperature will the water or the moisture start condensing using dew point. All right. So if let's say you don't understand or cannot imagine it, then just imagine upside down a cup of cold water on the top, on the external surface, and internal surface is the warmer environment, is a hotter environment, and then you will be able to remember. All right, hotter inside, colder outside, then you have some chance of condensation. Of course, here not all cases will, not all hotter environment will actually cause condensation. It depends on whether the surface itself reach below the dew point or not. All right. So you can always refer to the source of the slide to look at the table, right, that we included in the slide. Okay, so the effect of this condensation, especially for smelting plant, because of high temperature processes, is that there will be large amount of condensation happening underneath the roof. And eventually this will accelerate corrosion of the metals as well, right? So this is another extreme case where we have actually studied. And not just the roof, sometimes even the wall also will be having this kind of effect. Okay, so this actually depends on the location of the furnace and wherever places where it will generate a large amount of heat. Okay, and yeah, so on close up, some of the actually corrosion could actually also, because of the condensation and perhaps the environment is dusty, it could actually have accumulation of dust on the surface as well of the condensation, right? So how do you address that? All right. So one way to do it is to have a proper ventilation. Okay. So this one, if I can totally relate it to if let's say you have a humid room, right? Very humid, wet room. So the typical way people solve it if let's say your house is humid is open the window so that you let the air circulate to bring in fresh air. Not just that, but to bring in, to have that humid air get blown away, right? So having a sufficient ventilation is very crucial. And of course, some people might ask, oh, how about if I use a jack roof, right? So based on our studies, sometimes even the jack roof is not enough. Okay, the natural or so-called the passive ventilation sometimes will not be enough to reduce the internal surface temperature to internal air temperature to below and to above the to below the dew point. Yeah, sorry, above the dew point. Yeah. Anyway, so another way to actually address this issue is by increasing the roof height. Okay, so how do you how does it make sense, right? So let me just put this graphical example, right? So just now I pointed out the example was 40 degrees Celsius internal air temperature. So let's assume the furnace temperature itself is around 500 degrees Celsius, right? To show the whole picture. So if let's say you increase the roof height, what will happen? Okay, so the same level where I measured the 40 degrees Celsius will still maintain at 40 degrees Celsius, slightly or maybe slightly below because there are more places for the air to go. But if let's say increase the height of the roof, what will happen is that because the heat has more place to go, the air has more place to dissipate the heat, then the air around the roof will be lower, okay, it will be reduced. So in this case, it would not reach the dew point that I mentioned earlier. So it would not cause internal condensation. Okay, and this will help prevent the any sign of condensation happening. And last would be quite straightforward. This one, introducing a vapor barrier that is not reactive to moisture. So of course, in our previous episodes, I believe if let's say those who join, you know that we always refer to this vapor barrier, right? So in this case, this vapor barrier has to be non-reactive to moisture or not absorbent, meaning it will not absorb the moisture, okay? So that it does not transfer the moisture to the roof, okay? And of course, sometimes people ask, oh, what is vapor barrier? Can you give me an example? So vapor barrier is not like a board that where it's not like ceiling. Sometimes some ceiling they will actually have the moisture transfer through the board and then go to the roof. All right. So for example, insulation, like mineral wool insulation, it actually is porous, so the water can be transmitted through the wool itself. So it is not a vapor barrier. A vapor barrier is where you have a barrier that is closed cell that does not have any porosity, right, to transfer the moisture through the membrane. Okay, that's what we call vapor barrier. So in order to prolong the roof or the cladding, even sometimes the steel structure, then a vapor barrier would be a solution to go. All right. So with that, let's summarize today's two topics and two different aspects of two different types of industry. So for the first one, palm oil mill. So what should you do, right, to actually address the internal condensation or so-called prolong the lifespan of the building or the cladding? First, you should consider a design that releases the steam externally, right? When I say externally, it means the steam will not get blown back into the building as well. Okay. And the second one that is relevant to this that I highlight in the second one is actually additional vapor barrier. So what will happen is that if let's say you introduce the vapor barrier, so it will not absorb. I mean, the steam that is released will not be absorbed by the vapor barrier, and the vapor barrier themselves are non-reactive to the steam. So in a way, providing an internal shield, to shield the steam from the roof or any types of steel structure or metal structure. Okay, and on the second topic of smelting plant, all right, so we covered three types of solution. Okay, so the first one is having a sufficient amount of ventilation, right? How sufficient is sufficient? That depends on your building design to ensure that the temperature internally does not go too high, right, near the roof, right? Hence preventing condensation. A second one is to increase the roof height, right? So this one will achieve the same effect as increasing the ventilation. It is actually to reduce the surface, the internal air temperature. And the last one is additional vapor barrier to be installed underneath the roof, right? Or sometimes even underneath the steel structure. Okay, so all these are some of the possible solution that you can aim forward to if let's say you're an engineer designing for this kind of building, all right, or any similar processes that involve high temperature or emits out steam in the process in the building. Okay, so with that, let us just go to the next session of today's webinar, which is question and answer. So let's see if we have any questions. All right, so let's address from the Q&A first. Okay, then I believe we have a question posted from the chat. Sorry, I actually don't see the question posted from the chat. So could you kindly post it in the Q&A so I can actually see it? Thanks. So let's address the question one by one. So so the first question is Lee, okay? So can we reduce the RH in the building so that the condensation will not happen on the bottom side of the roof? So the answer is, like I presented earlier, the answer is yes. So you can actually try to reduce if let's say you're referring to the steam, then yes, you can actually try to reduce the RH internally. Okay. The reason why I say this is because when you talk about relative humidity, right, it looks at how much moisture is in your air. So if let's say your processes involve steam, so steam is basically introducing more moisture into the air. So if you want to reduce the RH for this kind of industry, like involves steam one, right, like palm oil mill, then you need to eliminate the introduction of steam internally. And if let's say you're talking about high temperature processes like smelting plant, then yes, there is also a possibility, just like how I referred to the explanation on if let's say your room or your house is humid, then your perfect solution or your normal solution will be open up the window to have ventilation. So having a sufficient amount of ventilation to make sure that the air is not too humid is one of the way to go. Of course, there's a catch to opening the window and then letting air out, right? So having the air out, that means something will come in also, right? So the air that comes in needs also to be drier than the air going out. If let's say the air coming in is having a higher relative humidity than the air going out, then you're making the situation worse. So yeah, it has to consider. I mean, you have to consider the scenario here, right? But other than that, if let's say that doesn't work, then you can actually introduce the vapor barrier, right, to actually address the issue. Okay, so so far I haven't seen or know of any dehumidifier that's for industrial grade. Perhaps someone who has it, then yeah, probably will be a solution as well. Okay, so let's go to the next question. Yeah, so I think, okay, probably there are some kind of air dryer that can reduce the RH of a building. So this is from the same participant, Mr. Lee. So yeah, like I mentioned, there could be a possibility of a dehumidifier for the industrial grade one. But so far I haven't heard of any myself. So smelting plant will be so hot that the bottom surface of the roof will be well over 100 degrees Celsius. So condensation won't happen, right? So on the contrary, so like I mentioned earlier, so I think it's better for me to go back to the slide so that you can actually have a better perspective, right? So here you can see what happened is that if let's say the internal air is higher than 40 degrees Celsius in this scenario, what will happen is that for example, in the same RH of 50, what will happen is that your dew point would be at, For example, if let's say internal air temperature is 46 as opposed to 40, the dew point is actually at 33 degrees Celsius. So what it means is that if let's say the roof temperature or the outside temperature is 33 degrees Celsius, then you still will get so-called condensation happening on the inside because it's hotter and more humid, right? If let's say the temperature is well over for the air, well over 100 degrees Celsius, then I would imagine the dew point would be well over 30 or 40 degrees Celsius, right? So in that case, it's over the normal temperature during the day also. So what it will happen is that even during the day, there will be condensation happening underneath the roof. And yeah, this will be worse compared to colder temperature. So there are, whether increasing the roof height can actually do the job in this scenario, I'm not very sure. So it needs to actually depend on the simulation and also the designer's recommendation. Right? So I hope I answer your question, Mr. Lee. So next one is Ling. Okay, so does the thickness help in terms of corrosion resistance performance? All right, so I think you're referring to if let's say the roof itself, you're expecting moisture to condense it on the underneath of the roof, right? Then whether increasing the material of the roof will actually increase the lifespan, if let's say that's what you are referring to. My answer is yes, it will increase the lifespan of the roof, but not by significant amount. So the reason I say that is because if let's say there is frequent condensation happening internally, it will actually accelerate the deterioration very fast. So just now, I'm sure most of you have answered the poll. How soon do you think for palm oil mill you need to remove? And most of you say 5 to 10 years. But in specific scenario like the sterilization process, sometimes it can even be 1 to 3 years, 3 to 5 years time span to change the roof. So by increasing the material of the roof, it might extend it by a few months or maybe 1 or 2 years, but it won't go beyond that, right? So yes, the answer is yes, it will increase or improve the resistance or lifespan, but it won't be a very significant solution for you to address the long-term issue. Next one, I think from same person, Ling, can I overpaint my roof if found internal corrosion due to condensation? So yeah, if let's say you saw there's rusting happening underneath the roof, right? So whether painting it will solve the issue. So my answer is yes and no, right? Yes, because if let's say you do it properly, removing all the corrosion product and meaning the rust and also the white rust oxidation, and then paint away using a suitable paint in the suitable condition, cure it properly, then yes, and then leaving no gaps or no leakages to expose to the same type of environment, then it could be a short-term solution as well. How long it will last, that is depending on so many factors I mentioned earlier, right? The temperature, curing temperature, the type of paint, the condition of surface where you paint over it. So the no is because, yeah, it depends on too many factors. Most often, owners will get 1 or 2 things wrong, and then the result will be bad, right? So my answer is yes and no. Yeah. So move on to any warranty will be issued for this type of building, right? So from Chin or Feng, yeah, Feng. So in terms of warranty, if let's say this type of building, you can address the internal condensation issue. For example, if let's say you can confirm that, or in actual fact, there's no sign of condensation, or in actual fact, no steam being released internally, right? Then from a commercial perspective, again, we comment on the commercial perspective, and since you're asking about warranty, the answer is yes. I think it is low risk for us to take up the responsibility by warranting the material. But if let's say in this kind of environment where the steam itself is exposed, I mean, it's the building or the material itself is exposed to this constant bombardment of moisture, I think the risk is too high the chances of failing is too high, and hence it's illogical for us to offer a commercial warranty, right? And yeah, it doesn't make sense. So we rather not offer the warranty to make sure that you are aware of the issue and address it using, say, vapor barrier or any types of design innovation by an engineer. Then yes, it's possible to have a discussion on the commercial part, which is warranty. Okay. So next question, can you provide some example of vapor barrier that is available or currently in use in the market? Oh, well, all right. So if we are talking about vapor barrier, just now I mentioned the characteristic of vapor barrier is that it needs to be shielding the vapor, also called steam or water, moisture, from going through the membrane from the barrier towards the roof. So what happens is that you can have some kind of polymer membrane, right? That is closed cell that doesn't transmit water through the membrane. You can have foil, like aluminum foil. I've seen many cases where people use aluminum foil, but the thing is with aluminum foil, some of them might actually be not so strong. So you might want to consider a stronger one so that it will stay intact for a longer period of time, right? Again, but if let's say you're talking about aluminum foil, it is a type of metal in the end. So it will have a reaction as well. If let's say it's exposed to moisture on a long-term basis. So it will oxidize, and I'm not sure how long it will last, but that is for an actual study to happen, only then we will know roughly how long it can last. Okay, so the next question, is it common for smelting plant to install aluminum foil or insulation or vapor barrier? So we have not seen for smelting plant factories where they will have cladding and then install with an aluminum foil as the vapor barrier. Yeah, for smelting plant, no. Probably because what people would think is that, oh, the foil might melt or whatnot. So again, it comes back to how durable is the foil itself, right? In order for it to be feasible in the environment. So one keyword that you can always ask your supplier is, what is the working temperature? What is the service temperature of this material? Can it withstand, say, moisture exposure for frequent on a frequent basis, maybe once every hour, depending on your how you operate your smelting plant, right? How often is it that you see condensation? Okay, so how do you measure RH of a room or space? All right, so this question, well, there are actually devices that measure the relative humidity of a room from a very old school way to a very high tech way. From you can simply buy a humidity measurement machine online for less than 50 ringgit, and is accurate to the percent, to the 0.1% or 0.5%, right? So it's possible to actually measure it using device that actually measures dry bulb temperature and wet bulb temperature, and from there you can actually measure the relative humidity along together with the what they call the psychrometric chart, right? So that is a very old school and a very mechanical way where engineers normally, if let's say they have that device, then they will actually refer back to the chart, right? So yeah, so some So there are many ways to actually measure it, to answer your question. But if let's say you want to know or your room, what is the RH of your room or the space, you can definitely spend less than 50 ringgit to buy the machine, thermostat, to measure the room's RH. Okay, so all right. So any more question? Any paint system that can be used instead? All right. So I'm not sure whether you are referring to our product or you are referring to, if let's say there is any oil painting happening, then what kind of paint system to be used, right? So I actually dare not comment on the specific brand or so-called types of formulas that you should use. But any types of paint, if let's say you want to fix the problem or rather use it as an initial solution, also should have the characteristics that I mentioned for the vapor barrier. Okay, so first it is that it needs to be non-permeable, meaning water would not go through this paint to react with the metals, regardless of what kind of metal you have, right, as a roofing. Um, uh, some of the possible solution, I think for the building I-beams, normally they use epoxy paint, right? So possibly along that line, or epoxy or sometimes PU. But again, you need to clarify with the paint supplier whether it is able to be non-permeable, right? Or whether it can even resist the high temperature that is exposed to, right? Just now, one of the participant actually said in smelting plant, it could go up to 100 degrees Celsius for the roof area. So yeah, maybe you can ask the paint supplier, can your paint, is your paint serviceable, or the service temperature is 100 degrees Celsius? If let's say they say yes, then yeah, perhaps it's suitable to be used. All right, so next question. What's the most suitable roofing product would you recommend to be used in palm oil or smelting plant as roofing, assuming there is vapor barrier? Okay, so this is from Ryan. So Ryan, actually, this is a very good question. So uh, in terms of material, all right, so you need to look at, so the internal has already been addressed by this vapor barrier, assuming, right? So the threat, or so-called the risk of failure coming from internal, will be reduced greatly because of the vapor barrier. But sometimes there will be uh, external issue, such as normally smelting plants or so-called palm oil mill, they will be positioned or they will be located at very heavy industry. All right. So in the industrial area, some of the examples that I can refer to is, for example, in Johor, you have a lot of palm oil refinery, right, in Pasir Gudang. So in this area, the internal is facing the risk of steam. So if let's say you eliminate that risk, external, you're looking at surrounding and even your stacks, right? What kind of material you are burning to produce the energy. If let's say the chimneys themselves release out corrosive substances like sulfur dioxide, uh, chlorine, any types of industrial emissions that could also jeopardize the roof, then you are supposed to look for a product that is longer lasting. So for our product, of course, I try not to involve our product in this session. But if let's say you were to look at our product range, the ones that is suitable for corrosive environment, right, would be suitable for this kind of industry, right? Something like Ultra, right, with a coating class of AZ 200, right? So again, at the end of the day, we are aiming at longevity for our building, right? So that you will spend the least amount of maintenance or so-called downtime to actually maintain the same building, or so-called the condition of the building. And just now I did mention something is that for smelting plant, if let's say the roof start leaking, what will happen? Because the places where it will start leaking first will be right above the smelting or the furnace, because it's the hottest. So what happens is that you have leakages during the rain. And imagine if let's say there's drops of water, keep dropping onto the furnace and onto the molten metal, then you have a scenario of spattering molten metals all over almost all the time, if not, during the rain. Yeah, so spending a good amount of initial thoughts to designing is very crucial. And I hope the session today is able to raise awareness to what you are looking at, and also what could be the possible solution. I remember, just to share further, not addressing to any questions. Of course, if anyone have any questions more than what we have addressed, I mean, any questions related to this topic, and you haven't typed in the question, please do so while I'm still sharing some some insights. So I remember conducting once a site visit to a smelting plant, and the engineers actually told me that sometimes they encounter water droplets coming out of nowhere at night. There will be drops of water, but then when they look up, there was no leakages. And during the day, or during even heavy rainy day, there was no sign of leakages. So what is the explanation for that? So that was a riddle for them. So my answer to that was condensation, right? Because the internal temperature was so high and the air was so humid that the condensation happening underneath the roof. And then because the water droplet is so heavy, right, it start dropping, right? So much water that it condensed onto the surface, then it start, dropping. So that caused the water droplets, right? And they thought was actually leakages. So sometimes people will be unaware of the effect, right, of this type of industry. So so this is why we actually have this kind of session. All right. So I saw a new question. Any specific type of material for accessories such as fastener for this kind of environment? Yeah. So so far we have addressed the concern of condensation, or so-called steam, onto steel cladding or sometimes a steel structure. So how about fasteners, right? You have to lock the cladding down, to the structure by some kind of fastening mechanism, right? So if let's say you are using a type of fasteners, then my recommendation is that if you are looking at class 3 and class 4, those are normally refer to the corrosion resistance of the fasteners against external weather. But if let's say internal weather is humid and you have condensation happening all over the fastener, you will soon have a risk of the fasteners corroding on the shank or locking area as well. Then my recommendation off the top of my mind would be try to also shield the fastener from exposing to the moisture or the humid air. So how you do it, actually, it depends on engineers designing, detailing and all that. I have no experience on that, but I have experience seeing fastener fails due to all this kind of funny environment. Yeah. So so I hope I addressed everyone's question. And if let's say you have more questions that you cannot think of right now, and want to ask us, on a separate time, feel free to refer to these different channels to contact us. And yeah, we hope to hear more from you if let's say you have more questions. All right. So with that, thank you for joining us for today's Steel Connect webinar, and we hope to see you again soon. Thank you. Bye.